Hey everyone, welcome back to CodeStreak Daily. In today's video, we're gonna solve the Leetcode problem, and the problem name is maximal score after applying k operations, and it's a medium level difficulty problem. So in today's video, we'll be solving a very fun problem where we'll maximize our score by performing operations on an integer array. So let's see the description of the problem. You are given a zero indexed integer array nums and an integer k. You have a starting score of 0. In one operation, choose an index I such that 0 less than equals I less than nums length of the integer array, and we have to increase the score by nums of I and replace nums of I with we have to do an operation nums of I divided by 3, and we need a seal value, not the floor. So we have to import my math library, math.sil. We can use that. If not, we can try if we can do that in the easiest way. Then we have to return the maximum possible score we can attain after applying exactly k operations. The ceiling function will have a seal val is the least integer greater than or equal to val. Okay. So here we have an array with 5 elements, and all the elements are 10, and we have k equals to 5 and the output is 50. Apply the operation to each array element exactly once. The final score is 10, the sum of the array 50. Then we have another example where the elements are 1, 10, 3, 3, 3, k equals to 3. That means we have to apply the operations only for 3 times. We have the output 17. So for the first operation, we have to select I equals to 1, that is 10. So nums become 1, 4. 10 is replaced with 4, and your score is increased by 10. Then in the second operation, we have to select I equal to 1, so nums becomes 2. Then our score increases by 4. And at the third operation, we have to select nums I equals to 2, and nums becomes the third index value will become 1. So we have to increase the score by 3. The final score will be 10 plus 4 plus 3 equals to 17. So here what we have to do is the basic thing. We have to select an index I where index I will be 0 less than equals to I less than nums dot length. So it must be in the range between 0 to length of the array, and we have to increase the score with the value that of the index that we have chosen, and then we have to replace the value with the answer that we get when we divide the value by 3. It should be a seal operation, not a floor value. Okay, so that means if 10 divided by 3 with a seal value, then we will get, if not for a normal division, 10 divided by 3, we get something around 3.333. So when we take the seal value, we will get the answer as 4. Okay, so we have replaced 10 with 4, and our score will be increased by 10, the element which was previously here. Okay, so now here we have to replace the 10 with 4. In the second operation, we have to divide 4 by 3. Then we'll get something around 1 point some change. So if we take the seal value, we'll get the value to 2. Then we have to replace 4 by 2 and increase our score by 4. Okay, then again we have to select 2 divided by 3, and the seal operation will take it to 1. Okay, so now we have to sorry here 2. So it is not satisfying this condition. Okay, then we have to take the next element 3. When 3 divided by 3, that may be seal or floor, it always results in 1. So we have to replace 3 with 1. So after we have completed k operations, then we have to check the final score. So here we have replaced 3 elements with 10, 4 and 3. Then our score will become 10 plus 4 plus 3 equals to 17. Okay, so the problem is pretty straightforward. We are given a list of integers and an integer k. Our goal is to perform exactly k operations to maximize our score. Okay, we have to do the following operation. These operations we have to perform. These 3 operations we have to perform. Okay, now let's go ahead and write the program. So we import 2 essential libraries. Here I'm also taking the heap. Okay, I'm also taking the heap here to manage the heap operations, and I said I have to import the math library to use the seal function. Okay, so I'm writing it here, import heap queue, and as well as I'm taking import math. Okay, I'm taking import heap queue and import math. Now Python heap queue module only supports the min heaps. Okay, to simulate a max heap, we have to store the negative values of the array elements. This way, the largest element becomes the smallest negative integer. Okay, so I'm taking max heap equals to, as I said, we have to take the negative value minus num for num in nums. Okay, here I'm making it as a max heap. Then I'm taking heap queue dot heapify. I'm making it max heap. Okay, now we have to loop exactly k times, where in each iteration we have to perform some operations. Okay, we have to extract the largest element by popping the smallest value from the heap queue. Remember, values are negative, so we multiply by -1 to get the original value. Okay, so for that, um, I'm taking score equals to 0 first, and we have to perform the operations, right? So for that, I'm taking a for loop for, I don't need a variable here. I can use the underscore also for underscore in range of k, because we have to loop it for k times only. Now we have to extract the largest element. Okay, so max underscore element. I'm taking a max element. As I said, it is already in the negative. We have taken the values in the negative manner. Then I have to multiply it by -1 to make it positive. Okay, so directly I'm taking minus heap q dot heap pop of max underscore heap. Okay, now we have to add this element to the score. So score plus equals to max underscore element. We have added everything. Now the new value will be there. No, now new value will be equals to math dot seal max element by 3. Okay, now we have to push that again. Heap q dot heap push of, where you are pushing, we are pushing it into the max heap. What we are pushing? The negative new value, right? Negative new value. What we are going to return? We are going to return the score. That's it. Okay, so after the k iterations we will get the score. Now let me run and check. See, uh, the test cases are accepted here. Let me submit the code and check. You can see here our code is perfectly working fine. It beats 56.64% of users, and we have a runtime of 729 milliseconds. Okay, that's okay, not bad value. Okay, so for this we have a time complexity of the solution is order of k log n, because in each of the k iterations we are performing a heap operation which will takes order of log n time, and for k operations the overall complexity will go up to order of k log n. Okay, which is efficient enough for typical constraints. So that's good, and that's how we maximize the score after performing k operations and the array. And if you enjoyed this explanation and found the code walkthrough helpful, make sure to like, share and subscribe to the channel. Don't forget to hit the bell icon so you don't miss out any new videos. Thanks for watching, and I'll see you in the next one. Check out more coding challenges and solutions here. Keep up with your daily code streak, and happy coding.